some of the formulas on the back of the purple sheet. Now this side I'm going to duplicate and attach to the test. So you don't need to know this side. So the side that we're on now, you do not need to memorize. Okay, so you will be given these formulas. Okay, so what we're going to do using the sum and difference identities is find the exact value, and we're going to need our unit circle. So go ahead and take that out also if you don't have it out. So go ahead and copy down. You don't have to copy down these formulas again because those will be provided. So go ahead and copy down this first example. We're going to find the exact value for the cosine of 75 degrees. So for the cosine of 75 degrees, 75 is not an angle on the unit circle, right? There is no 75. So we need to find either two angles that we can add to get to 75 or subtract to get to 75. So let's go ahead and add. What two angles that we have on the unit circle, what two angles can we add to get to 75? Well, we'll do it in degrees.
16, 30, and 45.
30 and 45. Would you agree that 30 plus 45 is 75? Okay, so we're going to do the cosine addition. So I'm going to write that formula out. And you don't have to if you don't want to, but I'm on the side that says sum because we decided we're going to add instead of subtract. You have a choice of adding or subtracting, but we're going to add. And because it's cosine, I'm looking at the cosine addition formula, which says you take the cosine, and in this one we said, and it doesn't matter with addition, because for addition, 30 plus 45 is the same as 45 plus 30, right? So it doesn't matter if we call alpha 30 or 45. So I'm going to say that alpha is my 30-degree angle. Beta is my 45 degree. So every place where you see an alpha, you're going to put a 30. And every place where you see beta, you're going to put 45. So we have cosine of 30 degrees times the cosine of 45. And we're adding to, or not adding, sorry, we're subtracting from that the sine of 30 degrees times the sine of 45 degrees. So go ahead, take out your unit circle, because these are four numbers on your unit circle. So on your unit circle, I want you to figure out these four numbers. The cosine of 30 degrees, the cosine of 45 degrees. So go ahead and figure that out looking at your unit circle. The sine of 30 degrees and the sine of 45. So go ahead, take a moment in your unit circle and find those four values. Cosine of 30 degrees. The cosine is positive root 3 over 2. Is that correct? Okay, so I'm going to put that here for the cosine. And then what's the cosine of 45? Root 2 over 2. The sine of 30 degrees is 1/2. And the sine of 45 is root 2 over 2. So when you're multiplying, you don't need a common denominator. And you can multiply two radicals together. Okay, if they're different, we can still multiplying. So this is going back to some algebra skills. So you can take the 3 and the 2 and multiply them together, and it becomes a 6. So we end up having the square root of 6 over 4 minus, now when we multiply this across, we get the square root of 2 over 4. And because we have one denominator, the same denominator, we can combine that and make one fraction. So this would be my final answer. That's the exact value of the cosine of 45 degrees. Now, what I want to make sure you understand is we can multiply, but we can't subtract. So you can't say that this is equal to the square root of 4 and then say that the square root of 4 is 2, and then that's 2 over 4, so you get 1/2. No, that's not how that works. You can multiply, but you can't subtract. That would be your final answer. And that's it. Okay, so let's do another one. Go ahead and copy this one down. This is in radians. So, which is fractions, which might be a little bit harder. And I will tell you, because 1/12 is a small number in degrees, you will have to subtract 2 angles in radians to get pi over 12. Pretty sure he did this in the video yesterday, so if you watched the video, this is just a repeat. But what 2 angles can we subtract to get pi over 12? So I think the hardest part is recognizing it as a common denominator, because 4 pi over 12 is the same as pi over 3. And 3 pi over 12 is the same as pi over 4. Because you have to look at the angles in terms of a common denominator. So you're taking 4/12 minus 3/12 to get 1/12. So my angles, I'm using the cosine difference formula now. So if we look at that, that says cosine. Now alpha, because it's subtraction, when you're dealing with subtraction, order does matter. So it does matter that we use the bigger angle for my alpha angle. So we have to make sure that we put pi over 3 minus pi over 4. So that is important. Addition, 30 plus 45 is the same as 45 plus 30, okay? But 45 minus 30 is not the same as 30 minus 45. So we have to be careful with difference. So my alpha is going to be 4 pi over 12, which is the same as pi over 3. Minus pi over 4. So find the difference formula where it says cosine difference. And you're going to have the cosine of alpha, which is pi over 3. So go to your unit circle, figure out what that angle is. And we're going to multiply that by the cosine of beta. And now we have addition. And we have again the cosine. So go ahead, go to your unit circle. And do the same thing. Find those numbers, except this time we have addition. We're adding according to the theorem. Yes. Oh, it would be sine. Thank you so much. So what is the cosine of pi over 3? Okay, and then cosine of pi over 4. Okay, and the sine of pi over 3. And then we have root 2 over 2. So when we multiply, first we're going to do order of operations, which is multiply first, which is going to give us root 2 over 4 plus root 6 over 4. And because it already has a common denominator, this would be my final answer. So they have to be like terms, and for it to be like terms as a radical, it has to have the same number under the radical. So for example, if you have the square root of 3 plus the square root of 3, that becomes 2 square root of 3. You still don't add what's under the radical, but you can pull them together because they're like terms. Okay. So that's cosine. So now let's look at the sine formula. Go ahead and copy down. Oh, sorry. Go ahead and copy this one down so we could look at this one. So determine which identity is being used here. So what identity has cosine, cosine minus sine, sine? Go ahead, look at your purple sheet. So what identity has cosine, cosine minus sine, sine? Is that a sum or a difference, first of all? It's the sum, and which sum is it? Is it the cosine or sine sum? So this is Cosine Sum Formula. Okay, so for Cosine Sum Formula, this is telling me that alpha is 70 and beta is 20. So this is saying find the cosine of 70 plus 20, which is what? What is 70 plus 20? 90. Now tell me what is the cosine of 90 degrees, and that is your final answer. So the main thing we're trying to figure out is, are we adding or subtracting, and what trig identity are we using? But again, this is cosine sum, and because it's cosine sum, we're adding. And the cosine of 90 degrees is what? Is that 0 or 1? So that would be your final answer. That would be your exact answer. Go ahead, copy it down, figure out which angle we're using. I mean, is it a cosine or is it a sine? It's either cosine or sine. And is it sum or is it difference? So are you adding or subtracting pi over 12 and 7 pi over 12? So go ahead and look at that. Okay, so which identity is this? Is this sum or difference? Cosine, cosine minus sine, sine. Sum again. So you're going to add pi over 12, and we made it simple. You have a common denominator. So that's going to give you 8 pi over 12. which can be reduced down to what? What is that reduced down to? 2 pi over 3, yep. So what this is asking you for is the cosine of 2 pi over 3. Go ahead, look at your unit circle. And what is the cosine of 2 pi over 3? Negative 1/2. Who agrees with that? That is negative 1/2. So that would be your exact answer. So now let's go to our sine formula. So that's the second row. So we have to get to 7 pi over 12, and we have to figure out how we're going to do that. Are we going to add 2 angles or subtract 2 angles to get to 7 pi over 12? We're going to add. So we're going to do our sum formula. And we're actually going to add because if you take 3 pi over 12 plus 4 pi over 12, you get 7 pi over 12. Okay? And there may be another way to get, let me see, can we get there with 2? Yeah. So 3 pi over 12 and 4 pi over 12. So 3 pi over 12 is the same as pi over 4 plus pi over 3. So that would be your alpha and your beta. So we're doing the sine sum formula. Let me write that down. So sine sum formula, because this is we're looking for the sine this time, not the cosine. So let's go ahead. So for sine sum, it says take sine of alpha times the cosine of beta. So I'm going to take the sine of pi over 4 and multiply that by the cosine of pi over 3. And then what does it tell me to do next? Do I add or subtract? You're going to add the cosine of pi over 4 and multiply that by the sine of pi over 3. So take a moment, go to your unit circle, fill in all 4, and see what you get. Figure out the sine of pi over 4, the cosine of pi over 3, the cosine of pi over 4, and the sine of pi over 3. Cosine of pi over 3, 1/2. And sine of pi over 3 is root 3 over 2. So you multiply straight across. So my final answer would be root 2 plus root 6 all over 4. So we're actually going to finish this out Friday. But again, I'm just going through each of the 6 identities for sum and difference this week, which was also in the video that I posted for March 1st. There is a 50 points assignment that if you did not do, you really need to get that done. And homework 11, again, is due next week on Tuesday.